Good morning, class. Are you ready to learn today?
Yes, we are.
Great. Then let's get started. Today we'll look at the concept of force fields. The idea of a force field was created to explain how forces could act over large distances with no contact between the objects. Michael Faraday came up with the idea of a field of force so that objects could interact with the field at their location. He imagined lines of force that filled up space.
So, a large mass like the Earth will create a gravity force field that fills up all of space, and objects like the Moon will interact with the field?
That's correct. Charged objects can also create force fields in the space around the objects. To define the strength of the gravity field, we take the gravitational force divided by the mass of the moving object. For electric fields it is a little more complicated. The gravity field, little g, is the gravitational force divided by little m, the mass of the moving object.
Is the direction of the gravity field the same as the direction of the gravitational force?
Yes, it is. Gravity fields will always have a negative direction because gravitational forces are always negative. The field points towards the Earth, or any other big M.
Is this little g the same thing as the freefall acceleration that we looked at earlier in the course?
That is an excellent question. You are absolutely right. If we rearrange the definition of the g field, we get F equals mg. Newton's second law says F equals ma, so A equals g. We can define the electric field as the amount of electric force divided by the moving charge, little q. But there's a difference between gravity and electricity. Charge comes in two forms, positive and negative. To get the direction of the field right, we've got to be careful. A decision was made when the concept was first introduced that the direction of the electric field is the direction of force on a positive charge. Here is an electric field map for the field created by a positive charge. Remember, the lines shows the direction of force on a positive little q. Notice how the map changes if the big Q is negative. It will attract positive charges, so the vectors point towards negative charges. To calculate the field strengths, we can use Newton's law of gravitation for gravity fields. To calculate the electric field, we can use Coulomb's law. Notice if big Q is positive, E is positive and points away from big Q. If it's negative, E will point towards it. That's all for today.
Goodbye.